Welcome to Danish Academy. Today, we're diving into the fascinating world of self-organizing networks, or SON, intelligent systems that are revolutionizing how mobile networks are managed. As networks grow increasingly complex with thousands of base stations and diverse tech elements of SON, like base stations, controllers, and others, work together to enable the network's self-organization capabilities. For example, base stations transmit and receive signals, and controllers manage the network's operations technologies. Manual management is no longer practical. It's slow, costly, and prone to errors. Importance of SON. The autonomy of self-organization is achieved using different algorithms and artificial intelligence methods. SON automates critical tasks like automates configuration, optimization, and fault recovery. Reduces cost, improves service quality. For example, imagine a network handling a sudden surge of users at a concert. SON dynamically adjusts resources to maintain seamless connectivity. This technology is already critical for 4G and 5G and will be the backbone of the ultra-dynamic, high-density networks expected in 6G. The architecture of SON is designed to enable automation across different parts of the mobile network. Typically, SON functions are implemented in one of three ways: distributed, centralized, hybrid. In a distributed, self-organizing network, intelligence is embedded directly in network elements such as base stations, known as eNode Bs in LTE or gNode Bs in 5G, allowing them to make local decisions quickly without relying on a central controller. In a centralized, self-organizing network, most decision-making and optimization are handled by the network's operation and support system, which has a global view of the entire network. A hybrid self-organizing network combines both models, enabling faster local reactions while also benefiting from centralized oversight. These self-organizing network functions interact with various systems: the OSS and network management system for global coordination, the radio access network for tasks like load balancing and interference reduction, and the core network for tasks like mobility optimization. Types of self-organization network functions and core components. Self-organizing network is built around three core functions: self-configuration, self-optimization, and self-healing. 1. Self-configuration. This function allows new network elements, like a base station, to configure themselves automatically when they're first installed. Instead of manually setting IP addresses, software parameters, and neighbor lists, the node fetches these from the network and starts operating with minimal human involvement. Example: a new 5G gNode B is deployed in a rural area. Once powered on, it downloads its configuration files and connects to the core automatically. 2. Self-optimization. Once the network is up and running, self-organizing network continuously monitors performance and fine-tunes parameters to improve quality and efficiency. This includes optimizing handover parameters, transmit power, and load balancing between cells. Example: during peak hours, the network adjusts transmit power levels to balance the load between congested and underutilized cells. 3. Self-healing networks sometimes face failures, like a down base station or fiber cut. Self-organizing network can detect such problems and react accordingly. It may trigger alarms, reroute traffic, or even reconfigure neighboring cells to fill coverage gaps. Example: if a base station fails, nearby cells automatically increase power or change antenna tilt to cover the affected area temporarily. Benefits of self-organization network. The advantages of SON are transformative for both operators and users. By automating tasks, self-organization network significantly cuts operational expenditure. For example, reducing the need for technicians to manually configure base stations. It enhances quality of service. ensuring users enjoy consistent, low latency connections, whether streaming a movie or making a video call. Self-organization network also optimizes resource use, maximizing spectrum efficiency, like ensuring a crowded stadium gets optimal coverage without wasting bandwidth. These benefits make networks smarter, more cost-effective, and capable of scaling to meet growing demands. As when in different network generations, self-organization network has evolved with each network generation, adapting to new challenges. In 4G, features like automatic neighbor relations dynamically manage cell neighbor lists to ensure smooth handovers, such as when you're driving and your call seamlessly switches towers. Mobility robustness optimization minimizes dropped calls by fine-tuning handover settings. In 5G, SON handles advanced tasks like beam management for millimeter wave signals and dynamic spectrum sharing, allowing 4G and 5G to coexist efficiently on the same spectrum. Looking to 6G, SON will leverage AI to predict issues, for instance, anticipating network congestion during a major event, and manage ultra-complex networks with unprecedented precision. Challenges and limitations despite its strengths. SON isn't without challenges. Coordinating multiple self-organization network modules can be tricky. For example, one module might adjust power levels while another tweaks antenna settings, potentially causing conflicts if not synchronized. There's also the risk of incorrect decisions, like misconfiguring a base station due to incomplete data, which could degrade performance. Security is a major concern. Automated systems can be vulnerable to cyber attacks, such as hackers manipulating network configurations. Addressing these issues requires advanced algorithms, rigorous testing, and robust cybersecurity measures to ensure self-organization network remains reliable and secure. Emerging technologies and future of SON, the future of self-organization network, is exciting, driven by cutting-edge technologies. Artificial intelligence and machine learning will make self-organization network predictive. Imagine a network forecasting traffic spikes during a festival and preemptively optimizing resources. Cloud-native self-organization network will enable scalable, flexible deployments, running as microservices in virtualized environments for greater efficiency. An open radio access network, Open RAN, systems, SON will orchestrate equipment from multiple vendors, ensuring seamless integration, like coordinating Nokia and Huawei hardware. Conclusion to wrap up, self-organizing networks are essential for the future of mobile connectivity. They reduce costs, enhance performance, and make networks adaptive and resilient. As we move towards 6G, self-organization network, S integration with AI, cloud-native systems, and Open RAN will enable smarter, faster, and more reliable networks. Thank you for joining us at Danish Academy. If you found this video insightful, don't forget to like, subscribe, and hit the bell icon for more deep dives into cutting-edge technologies. Stay curious, and we'll see you in the next video.